Hello everyone, welcome to the second episode of the series Mastering Post-Processed Shaders in Unreal Engine. In our previous episode, we laid the groundwork by exploring the basics of post-processing and even created a few really interesting filter and distortion effects. For those who might have missed it, you will find a link to that episode in the description below. Today we are diving into the world of HLSL shaders, focusing on how to create complex HLSL scripts for our post-process materials. In this episode, I will introduce you to the fundamentals of HLSL scripting within Unreal Materials, and with an advanced example, I will also help you understand how HLSL exclusively gives you the ability to create a really complex post-process material within Unreal. So without further delay, let's get started. So I'm going to add a new material which I will be using for our HLSL demo. The first thing I need to do is add a custom node. This is where you will be writing all your HLSL scripts. So here I will be adding description to my node. And this code section is where you will be adding your HLSL code. Below that we have the output type. So you can return a single float value as well as a float 2, 3 or float 4 values. It's up to you. For instance, let's illustrate this with a basic example. Let me write a single return statement to return a specified color. So I will write return float 3 0 1 0. And with this, we are getting a green color as the output. Now we can also pass along custom input parameters in this input section. So let me pass a color node as input. I will adjust our return statement accordingly to take this color and pass the same as an output. Alright, so now whatever color value I'm passing as an input, the same I'm getting as the output. So now I can directly pass the scene texture node as the color input. This brings our main scene back. So now we can manipulate our code to modify the existing scene. For example, we can specify the return statement to return only the art channel, or maybe RGR channel, so it replaces the blue channel with the red channel. Understanding HLSL certainly opens up a world of possibilities, doesn't it? Now let me head over to the Visual Studio Code and write a very simple and practical HLSL function. The most basic example I can think of is going to be Grayscale. So let me write the code for that here. So Grayscale is basically a dot product of your scene color and a coefficient color value. Now it is possible to create additional functions inside your HLSL script as well. For that, we need to define a custom struct and then encapsulate the function within it. Let's quickly demonstrate how this works. First, we define a struct, and within this struct, I'm going to embed our grayscale conversion logic in a separate function. Next, we instantiate the struct within our main code and then call the grayscale function via the instantiated variable. Alright, so let's copy this code and paste it in our custom HLSL node in the material editor. We are going to pass the main color as well as the luma coefficient as input parameters over here. So I am getting some error. That's probably because I missed out the semicolon at the end. So now I can see our scene turned into grayscale. Now let's ask GPT to add some additional parameters in our code to allow further customization. Okay, so it is giving me few of the commonly used parameters like contrast, brightness, and gamma, and it's also modifying the code for us. Alright, so let me quickly update our current code. So I now need to add these additional parameters in our HLSL node. So let's do that first. Our grayscale shader is now complete, and with the additional parameters that we have added, we can effortlessly create various shades of gray. Now let's create something a little more advanced. So I will ask GPT to give me some advanced shaders that we can use with post-process effects. Okay, so I can see not all of them are actually a good example of advanced post-processing, but I like a few shaders over here. For example, this chromatic aberration and then this heat haze distortions and also the motion blur effect. So let's ask GPT to write an advanced shader using chromatic aberration and heat haze. Let's see what it comes up with this time. Okay, so now I will ask it to add the motion blur effect as well. Okay, so now let's copy over the functions in Visual Studio Code for further modifications. This shader is not going to be as simple as the previous one because there are few things that make this shader a really advanced one, and that includes the for loop that you can see in the motion blur function. And inside the for loop, you see the input texture parameter. It is quite understandable that this input texture parameter is going to be our scene texture node. But here, it is not just taking the color value of the scene texture node. Here inside the for loop, it is calculating its UV and then it is sampling the scene texture by the calculated UV at every iteration of the for loop. So we cannot simply pass the scene texture node as it is in the HLSL because then we won't be able to manipulate its UV. So for that, we have to define the scene texture within HLSL itself. And there is a way to do that, which I'm about to show you. So let's create the structure because we have to wrap all our functions inside the structure. And within the structure, we will define a function called getColor. We are going to pass the sampled UV as an input parameter to it. And inside getColor, we need to create our scene texture. And the way to do it is using this function scene texture lookup. For the scene texture lookup function, the first parameter is your UV. The second parameter is the scene texture index, which is 14 in this case. And the third parameter is a Boolean variable called bfiltered. So if you go to the scene texture node, here you see the scene texture ID parameter, and if you see in the drop down and count it from the very first value as 0, you will see the value of post-process input 0 is going to be 14, and that's also the parameter I'm passing. And also here you can see the bfiltered Boolean value, which is usually set to false, so that becomes our third parameter. And if you are using mobile device, then there is the function called mobile scene texture lookup with slightly different parameter calls. So let's use this if else condition, which will automatically check whether to use the mobile scene texture lookup or the scene texture lookup function. Alright, so I'm going to put the rest of the functions inside this struct. So wherever this input texture parameter is being referred, I am now going to use the getColor function instead. Also, wherever float 4 is being referred, we are going to change this into float 3. Okay, so there is a slight issue over here. It is just that what I'm doing right now is passing the getColor directly in both chromatic aberration and motion blur. So with this method, I will not be able to combine the effect of both of them together. What I want actually is to have the chromatic aberration applied on the scene first and then that output color to be passed as a motion blur. So for that, we need to put the content of both the functions outside the struct. So let's just do that. our code is ready. So now we need to test it. So let's create a new material. So here I'm going to create a new custom node where I'm going to paste this code. Now let's take a look into the input parameters that we need to pass in our script. For the UV, we can either pass directly the texture coordinates, or we can also define it inside the HLSL by calling the function getDefaultSceneTextureUV. And the rest of the input parameters we are going to pass from the material editor. So for the time parameter, we have this time node, which gives a sense of dynamic movement to your shader. So in our chromatic aberration shader, the UV of the RGB channels shift over time, and we can control that. We are customizing the speed value. Let's add the remaining parameters as well. Okay, so the output I'm getting is not quite clear. I guess it is just a parameter issue. So let's just tweak the parameters from the material instance. So now I see another issue where the right side of the viewport is having a different color and it's looking very weird. That is probably because the UV along the edges is being calculated incorrectly. So we need to adjust the UV a bit. So let's go back to ChatGPT and ask it to rectify the issue. It gave me a solution. So let's just implement that and see if it works. And there you have it, a flawless chromatic aberration post-process material where the RGB channels are uniquely shifted over time. And we made this by learning and understanding how HLSL works in post-process materials. Pretty neat, isn't it? Now we can modify our shaders with some additional time-based parameters that will let you customize and control how much you want to displace each of the RGB channels in a given direction. So that wraps up today's tutorial, and rest assured I am just getting started because there is so much more to the realm of post-processing materials that I am eager to share with you in the coming weeks. The shaders we are building in this tutorial series, among others, are also available on my Patreon page, so consider supporting me by becoming a member, and in return you will gain access to all these project files. The link is given in the description below. And finally, don't forget to like, share and subscribe to my channel for more such tutorials like this one. I will see you in the next video.